Hello students, in our previous video we discussed about the combination of the resistors, after that balanced Wheatstone bridge, next one unbalanced Wheatstone bridge, how to solve the problems based on the balanced Wheatstone bridge, at the same time unbalanced Wheatstone bridge. Okay, so right now today we are discussing about the what is the cell, what is the EMF. EMF means electromotive force. Next one, what is the terminal voltage. Next one is the internal resistance. Okay, so today we are discussing about the what is the cell. Next one is the EMF, electromotive force, but that is not the force. Next one, this is the internal resistance, and last one is the terminal voltage. Yes. First of all, what is a cell? Why we are using that cell? What is a cell and why we are using that cell? Actually, cell is a device that one maintains the constant potential difference across the electrodes. Maintains the constant potential difference between the ends of the conductor, that is nothing but the electrodes. Actually here, in case if you take one cell, that one consists of the two electrodes. One is the anode, second one is the cathode. One is at the high potential, second one is at the low potential. So right now, in case if this is connected to the external resistor, something one bulb, I am taking this is the positive voltage, means the anode, and this is the cathode. Here electrolyte is there. Electrolyte. The liquid is nothing but the electrolyte. So actually positive and negative ions, that is the charges are separated. This one becomes, one is the anode, which is the high potential, that is the anode, and which one is the low potential, that is the cathode. So here in between these two electrodes, some potential difference, constant potential difference is developed. When that is, those two electrodes are connected to the external, that is the load. Here I am taking something bulb. When we connected the bulb, then current is passing through that. So to maintain the constant potential difference across the ends of the conductor, we must and should require the cell. Cell is a device that one maintains the constant potential difference between the ends of the electrodes or ends of the conductor by means of the chemical reactions. Generally in chemistry you learn that one. So by means of the chemical reactions, or maybe second one is the physical work done, that is nothing but the mechanical action or mechanical work done. Okay, so two ways here, how we develop the potential difference across the ends of the conductors, that is nothing but the electrodes. So here first one is the chemical reaction, and second one is the mechanical action or mechanical action. By means of the chemical reaction, or maybe second one is the by means of the mechanical action. These are the two ways. So first of all, what is cell? Cell is a device that one maintains the constant potential difference between the ends of the conductor, or maybe if you take the electrodes, so between the ends of the electrodes. So that is the cell. Next one, what is the EMF? What is the EMF? Electromotive force. EMF. Electromotive force. Actually here this is not the force. This is not the force. Electromotive force, we are using the word force, but that is not the force. Due to some historical name, we are using that one only. Actually, there is a potential difference. That is the potential difference. So, what is this electromotive force? What is this electromotive force? Amount of the work done. Yes. When charges, yes, when there exists the potential difference, some potential difference, then positive charges are flows from the high potential region to the low potential region. So electrons, that is the negative charged particles, those are moving from the low potential region to the high potential region. So when there exists the potential difference, then only charges are in the motion. Otherwise, that one never be in the motion. That is the static, electrostatics. This is the charges are in the motion, current electricity part. So when there exists this certain potential difference, then only charges are in the motion. Then only charges are in the motion. So here, when there exists a certain potential difference, charges flows from the positive charges are flows from the high potential region to the low potential region. So means outside of the cell, positive charges are moving from the high potential to the low potential, but inside of the cell, inside of the cell, those positive charges are moving from the low potential to the high potential. Actually, generally we know that positive charges are moving from the high potential to the low potential. But here, when positive charges are moving from the low potential to the high potential, must and should some work is done. That is generally there is in NCERT book particularly they mentioned the one name, battery mechanism. Battery mechanism. So that is nothing but here that is the non-electrostatic force. That is the non-electrostatic force. So yeah, in NCERT book they particularly given that name. That is nothing but the battery mechanism. Okay. Yes. So here how this charge, this positive charge is moving from the low potential to the high potential, means compulsory some work is done. That work we are calling that is nothing but EMF. Work done, yes, try to observe. Actually potential is equal to work done per charge. Amount of the work done to bring a unit positive charge from infinity distance to the point in the electric field. In the first second lesson we learned that one. So according to the definition, delta V is equal to W by Q. Here unit positive charge means there is nothing but the W. So delta V or maybe V is equal to W. So means work done to move the unit positive charge from low potential to the high potential. So means that is nothing but the potential difference only. So here electromotive force, that is nothing but the voltage. That is nothing but the voltage. So units are the ohms. Units are the ohms. Don't get the confusion. Here EMF means that is nothing but the voltage only. That is the potential difference only. That is the potential difference only. Okay. Amount of the work done to move the charge throughout the circuit, including the cell also. Actually, positive charges flows from the high potential to the low potential. But when the charge is moving from the low potential to the high potential, so must and should some work is done. That is we are calling the EMF, electromotive force. What is the units for the electromotive force? That is the ohms. That is the old, not volts, old. So what about the internal resistance? What about the internal resistance? Here electrolyte is there. When charge is passing through that electrolyte, some opposition is offered by that electrolyte. Some opposition. That is nothing but some oppose. So when this positive charge is moving from the low potential to the high potential, so this liquid opposes the motion of those charges. That is we are calling the internal resistance. Internal resistance. Internal resistance generally denoted with the letter small r. Internal resistance generally denoted with the letter small r. So what about the terminal voltage? That is nothing but the voltage across the terminal voltage. What is that terminal voltage? Yes, try to observe here. Here I am taking this one is the something resistance. Capital R is the resistance, and this one is the cell having the EMF something E ohms. Resistance is equal to R. Current passing through it is equal to I. Here, this one must and should consist of every cell must and should consist of some internal resistance. Some internal resistance. That internal resistance is equal to R. So here I want to find out what is the potential difference across this. What is the potential difference across the external resistor? External resistor. For that one, apply the Kirchhoff voltage law here. So that is nothing but E minus current passing through this resistor is equal to I. I am asking you what is the potential drop across this resistor. That is nothing but according to the Ohm's law, V is equal to IR. Next one, minus what is the potential drop across the internal resistor. That is nothing but V is equal to IR, that is equal to 0 according to the Kirchhoff voltage law. Therefore here E minus, I am taking voltage across the resistor is equal to V is equal to IR. This is the resistance R. So means V minus I into R is equal to 0. Therefore V is equal to E minus I into R. Here V is called as the internal resistance. This is the internal resistance in case of the discharging. In case of the discharging, yes. This is the terminal voltage, not internal resistance. Terminal voltage in case of the discharging. In case of the charging, that is a V is equal to E plus IR. V is equal to E plus I. This is the in case of the charging and this is the in case of the discharging. So here we learned the four concepts. That is the what is a cell. Next, what is EMF, internal resistance and terminal voltage. Terminal voltage is nothing but the voltage across that resistor. Voltage across that resistor. In this circuit, what is the potential difference or voltage? Potential difference across this resistor. So V is equal to E minus IR. That is the, here this one is nothing but the terminal voltage in case of the discharging. This is the terminal voltage in case of the charging. Okay, remember that. Next one, combination of these cells. Next one, combination of cells. Here cells are connected in two ways, actually three ways. One is the series combination, second one is the parallel combination, third one is the mixed combination. Okay, generally right now we are discussing the just two. One is the parallel, second one is the series, or maybe series and parallel. First one is the series combination. Second one is the parallel combination. Parallel combination of cells. Parallel combination of cells. What is first one? What is series combination of these cells? So first try to observe. Here I am taking the two cells having the EMFs E1 and E2 and internal resistances R1 and R2. Two cells. We are taking the two cells having the EMF E1 and E2 and internal resistances is equal to R1 and R2. R1 and R2. Right now those two cells are connected in series combination. How those are connected in series combination? This is the symbol for this cell and this is the having the EMF E1 and internal resistance is equal to R1. And next one, that is connected to the second cell having the EMF E2 and internal resistance is equal to R2. So observe here, negative terminal of the first cell is connected to the positive terminal of the second cell and second, that is the negative terminal of the second cell is connected to the positive terminal of the third cell and so on and so on. So that means that is we are calling the series combination. Series combination. So right now this is connected to the terminal, that is the external resistor. That combination is connected to the external resistor having the resistance capital R. Having the resistance capital R. So here I am drawing the equivalent circuit. So equivalent EMF of this cell is equal to E equivalent and equivalent internal resistance is equal to R equivalent So this is the external resistor, capital R. External resistor, capital R. So due to these cells, I is the current passing through this circuit. I amperes current is passing through this circuit. When current is passing through this circuit, so here potential is dropped across these cells. Potential is dropped across these cells. Try to observe. Yes, that is the discharging. So A comma B, here this is the part, that one is nothing but B, A comma B. So voltage across the first cell is becomes V1 and voltage across the second cell is equal to V2. If we apply the Kirchhoff voltage rule also, we are getting it, no doubt. Okay, or maybe we are doing like that. Try to observe. Yes. So from here onwards, we are applying the Kirchhoff voltage law. Yes. So I am starting from the positive terminal of the first battery, that is the E1. Potential drop across this resistor is equal to I into R. Potential drop across the second, that is the internal resistance, second internal resistance IR2. Potential is increases. We are moving from the lower potential to the higher potential, therefore that one becomes E2 plus E2 minus potential drop across the first internal resistance, that is equal to 0. That is the IR1 is equal to 0. So means from here E1 plus E2 minus IR minus of I into R1 plus R2 is equal to 0. Is equal to 0. This is nothing but E1 plus E2 minus I into total, this is the R plus small r1 plus r2 is equal to 0. Here we want to find out the what is the equivalent resistance. What is the equivalent resistance? Same thing, apply the Kirchhoff voltage rule here for this one. That is nothing but E equivalent minus I into capital R, that is the potential drop across the external resistor, minus I into R equivalent is equal to 0. This is the equivalent internal resistance. So no need this one also. Compare those two equations. Compare, this is the equation number 1 and this is the equation number 2. Compare equation 1 and 2. Equation 1 and 2. Therefore, E equivalent is equal to E1 plus E2. R equivalent is equal to, that is the equivalent internal resistance. R equivalent is equal to R1 plus R2. R total, that is the total resistance in the circuit is equal to capital R plus R equivalent, that is equal to capital R plus R1 plus R. That is the total resistance. That is the total resistance. Here this one we are calling the helping manner. Helping manner. In case of the helping manner, when cells having the EMFs E1, E2, E3 and so on, En are connected in the series combination, in that situation equivalent EMF is equal to sum of the EMFs of the individual cells. That is nothing but E equivalent is equal to E1 plus E2 plus E3 plus and so on En. When N cells are there, okay, let's try to observe. E1 R1, first cell having the EMF E1 and R1, second cell having the EMF E2 and R2 and E3 and R3 and so on, En and Rn are connected in the series combination in the helping manner. In the helping manner. What is the helping manner? What is the opposing manner? Okay, we will discuss that one also. So first try to observe. Here N cells having the EMF E1, E2, E3, En and so on En. Then equivalent EMF is equal to, that is nothing but E1 plus E2 plus E3 plus and so on plus En. So what is the equivalent internal resistance? R equivalent is equal to R1 plus R2 plus R3 plus and so on plus Rn. What is the R total? Means total resistance in the circuit is equal to how? Capital R, that is the external resistance, plus R equivalent. This is the total resistance in that circuit. In case n identical cells, each of the EMF capital E and internal resistance small r are connected in the series combination in the helping manner. Then what is the equivalent resistance in that circuit? In that combination, what is the equivalent EMF? What is the equivalent EMF? That is nothing but n cells having EMF E plus and so on, n times. Therefore, E equivalent is equal to, that is nothing but the n E. Therefore, R equivalent is equal to n R. All the resistors are connected in series combination only. R total is equal to n R plus capital R. That is the capital R plus R equivalent. This is the in case of the helping manner. In case of the opposing manner, yes, observe. What is opposing manner? Yes, first we will discuss that one. Try to observe here. We have the two cells having the EMF E1 and internal resistance R1, EMF E2 and internal resistance R2. This is connected to the external resistor capital R. So this is a helping manner. Negative is connected to the positive, negative is connected to the next positive, negative is connected to the positive. So in case negative is connected to the negative, then what happened? Yes, try to observe. So this is the wrong connection. Wrongly connected. Here this is the external resistor. This is the external resistor having the resistance capital R. EMF E1, this is the E2 R1 and this is the R. So apply the Kirchhoff voltage law. Current is equal to something I amperes or maybe yes I1. If you take I1 also no problem. Yes, I am taking I that is nothing but the E1 minus I into capital R minus I into R2 minus, yes, we are moving from the low potential to the high potential. Therefore, E2 plus E2 minus I into R1 is equal to 0. Here, E1 plus E2 is equal to I into capital R plus R1 plus R2. So, from here onwards, I is equal to E1 plus E2 whole by capital R plus R1 plus R2. Actually, this is nothing but the R equivalent by R plus R equivalent. This is in case of the helping manner. In case of the opposing manner, try to observe. Same, apply the Kirchhoff voltage rule. E1 minus I into capital R minus I into R2 minus E2. Why? Because moving from the high potential to the low potential. So potential drop. That's why we kept the negative sign. Minus I into R1 is equal to 0. According to the Kirchhoff voltage rule, second rule. So here E1 minus E2 minus I into R minus I into R1 minus I into R2 is equal to 0. Therefore, E1 minus E2 is equal to I into capital R plus R1 plus R. Therefore, I is equal to E1 minus E2 whole by capital R plus R1 plus R. This is nothing but R equivalent by capital R plus R equivalent. So, right now observe, here E equivalent is equal to E1 plus E2. Here E equivalent is equal to E1 minus E2. Therefore, E equivalent in case of the opposing manner is nothing but E1 difference E2. High value minus low value. E1 difference E2. So here E equivalent is equal to, that is nothing but the E1 plus E2. Here R equivalent, internal resistance, effective internal resistance is equal to R1 plus R2. Here is also effective internal resistance is equal to that is nothing but the R1 plus R2. Okay. So here based on this concept we will solve some problems in the next video. Okay. Right. Bye all of you.